All right. So let's keep kicking. Let's go over our assignment that was due for today and then keep adding some stuff. I will not give you an assignment over Thanksgiving break, so you won't have anything to worry about there. But let's at least give ourselves a good stopping point leading into that. Okay. So uh, we've been starting to talk about inheritance. So through the extends keyword, where we can make a class be a superset of a previous class. So for example, we have this class called player here that we are now creating specialized versions of player. We wrote fighter last time. I think for your homework this time, you were supposed to write wizard, which is effectively the same thing as we did for fighter with just a little bit of twist and turn going on with it. Let's see. We talked about the super keyword. So super is how an instance of an object refers to the instance of its parent. And just to kind of reiterate that a little bit, if I go into, um, we did already write, didn't we write fighter? Here's our player. Missing a file here. Let me go to my projects. Otherwise, we'll just rewrite it again real quick. Oh, no, we got it. Okay. I don't know why that old one was loaded, but so last time we created a fighter and we said that fighter extends player. That is to say that a fighter starts off as a generic player. And the way we accomplish that is by calling our parents constructor right there. So the very first thing we can do, the very first thing we should do inside of our constructor for fighter is call our constructor for player. And if we look at our constructor for player, we see that this guy takes a single string as a parameter. Let me just make sure I have the recording going. I'm pretty sure. Yeah. Okay. Takes a single string as a parameter. So all we need to build a generic player is a string for the name. So fighter takes in that string for a name. Now, a fighter could take in additional things if it made sense for us to require additional stuff for a fighter. But a fighter only needs a name as we have it designed right now. And then what we do is we go ahead and ask our player constructor to go ahead and create our core instance of ourselves using that name. So this calls the player's constructor right here, which sets up the name, sets up a base hit point, strength, armor class, yada, yada, yada. Then within fighter, we modify a player. So after this line of code, so on line 8 here, and I think I've mentioned it several times, but the call to the parent constructor must be the first executable line of code in your constructor. These are comments, so these are for human eyes only. They're not part of the executable code. But this must be the first thing that occurs in your constructor. You can't put it somewhere in the middle down here and expect it to work. Now, you don't always have to call the parent's constructor. So as an example, as we were talking about inheritance last time, I mentioned that there is an invisible thing that lives here. Class player actually could be written as player extends object, where object is something already built into the Java language. And if I go to Java object class, take us here. Notice the constructor for object takes no parameters. So something that does exist here, another thing that's hidden from us here is that line right there. So inside the constructor for player, it is calling the no argument constructor for our parent. So if we do not write a call to a specific constructor, because some classes have multiple constructors, they have multiple ways of building something. So if we don't explicitly call the constructor we want to call, Java will call the no argument constructor of our parent for us to make sure the inheritance works. So this is an invisible line that's not required, just as this is invisible and not required. If we are the base class, the one that's inheriting from the generic Java object. All right, so something to keep in mind, these things do exist. We just don't have to write them as programmers, as a quality of life perk, let's say. If we were working with an older language, we would have to write those things. So I'm just including them as a example. So here, I'll just go ahead and put comment those out. It'll actually compile. It wouldn't actually be an error. We just don't have to write it. Okay, so player exists as itself, but it does extend object by default. So we get everything that a player is within fighter. The first thing that a fighter does is it generates its playerness. I guess that's a good way of saying it. So after line 8, at the very least, a fighter is now a player, and he's a fighter in name only. Well, then we further differentiate ourselves from a player by creating a couple of dice for rolling different things. And we've decided that a fighter has this additional resource called rage that maybe they'll use as part of their melee-based attack. So their fighters are probably swinging at their opponents with a sword, and maybe when they're all raged up in berserker mode or whatever, they hit extra hard or something. So we've just invented this additional resource, and their rage is some value between 0 and 100. Hopefully they don't get 0 rage, but we haven't accommodated for that. So it's possible that we might have a very docile fighter in certain situations. All right. We then also decided that the strength for our fighter is actually slightly enhanced. We say fighters are actually slightly stronger than generic players. So we take whatever the fighter's current strength is, which was set by the player's constructor. So inside of our player's constructor, we set strength right here. So we will get a baseline strength for our player. And then when we're building our fighter, we modify that strength to take whatever it used to be, and we add some value between 1 and 4 to it. Oh, and actually, I said 0 to 100 here. It's 1 to 100 for a D100 roll. All right, so their strength will have between a value between 1 and 4 added to it to make them a little bit stronger than a typical player. Same thing, the armor class for a fighter is a little bit higher than the armor class for a generic player. So we take whatever their previous armor class is that was set by the constructor for player, and we add to that 2 times a D4 roll. So some number between 1 and 4 times 2. We're just arbitrarily doing that. As we test the game, we might have to tweak that to make sure that fighters are hittable or something like that if they get too sturdy, too much armor class or something. Okay, so that's what our fighter looks like. Then what we did is we taught fighters how to display themselves. And what we did is we leverage our parents' version of display. So again, kind of exercising this idea of the super keyword. So remember this keyword is how an object refers to itself from within itself. So saying this dot means this instance of fighter. When I say super dot in this case, we're talking about the instance of player that was generated right here. All right. So super and this are very related, but one talks about your parent, one talks about yourself. Okay. So that's where we landed on fighter. For wizard, we decided we were going to differentiate ourselves from a player. So we're going to say a wizard does extend player. So they are a player, just like any other player. We'll create our constructor for wizard. Wizard is, we're Java, capital S for string. So wizard will take in the name as a parameter, and we'll go ahead and call our parents constructor. So this is call players constructor to build a generic player. All right. And we decided that a wizard is going to have a little bit lower strength, a little bit lower armor class, and they also have this new ability called mana. So we'll go ahead and remember we say everything should be private, and then we loosen the reins as we go. So we'll say private int mana. All right. And we could treat mana similar to rage. So if I come back here into our player here, I'm just going to steal these couple of lines just for speed. So we'll say this dot mana is equal to a D100 roll. We can decide to change that if we wanted to, but we'll just keep it the same as rage. So really mana and rage are effectively the same thing. They're just different names for an additional resource, where mana is like magic ability and rage is aggression ability or something, however we decide to incorporate it into our game. It's just our way of differentiating wizards from players. We'll go ahead and set the strength. We decided that a wizard has lower strength than a typical player. So we can go ahead and just subtract a d4 roll from a player's strength. So we make our wizard a little bit weaker than a generic player. You could have done something more custom for this if you wanted to make their strength just a little bit weaker or even more, even a higher rate degree of weaker, whatever you want to do is fine. Similarly, we'll make their armor class reduced, similarly to what we did for warriors. So now we have a wizard, which has lower strength than player, a lower armor class than player, and also has some mana, which is this brand new resource that we store locally here and we set right here. Now, mana is private because it's only accessible inside the wizard class. So if something outside of this needs access to it, we'll either need to loosen the reins on this or give ourselves getters and or setters to accomplish it. All right, we'll go ahead and teach a wizard how to display themselves. First thing we'll do is we'll ask our player to display themselves, so our parent to display themselves, and then we'll reference our mana here to show how much mana we have. In the end, in driver, we're no longer going to have players and um, uh, well, no longer have players fighting each other. We're going to eventually have fighters and mages fighting each other. So let's just go ahead, or fighters and wizards. So we'll say a wizard W is equal to a new wizard. Call this guy Chuck. And then we'll say ask our wizard W to go ahead and display themselves. And we should get their playerness calling their display method first, and then the wizard setting itself apart. Right here. So here's Chuck. He's got 23 hit points, 7 strength, 8 armor class, and he has 69 mana. Whereas Bob had 20 hit points, 10 strength, 16 armor class, and he has 75 range. All right, I think that gets us up to where we were with the homework assignment. So any questions about this? Let's see. I'm looking at chat in case people don't want to talk. All right. I'll go ahead and save that, and I'll share this on Slack. Oh, there's a question on Slack here. Yeah, Jonathan, that's fine. Whatever you want to do in your mind for differentiating our wizards and our fighters from players is fine. If you want to do it as a percentage of strength, where like a fighter has 25% more strength than a player, and a wizard has 10% less strength or something, that's fine. However you want to differentiate them, as long as in the end they are differentiated. All right, so now that we have our fighter and our wizard, we'll go ahead and create our ring, or arena rather, and we'll pass in our fighter and we'll pass in our wizard. I'll go ahead and get rid of player one and player two. Scale this line for right now, then we'll. All right. Now, let's look at Arena for a second. Arena, the constructor for Arena takes two things. So if I look at Arena here, and I look at my constructor for Arena, my Arena is taking in two players, player one and player two, or P1 and P2. Yet out here in Driver, I'm passing in a fighter and a wizard. Is that allowed? If the constructor for Arena expects me to give it two players, am I allowed to give it a fighter and a wizard? What do you think? Is this legal code or illegal code? This is part of our lesson on inheritance. We get any takers? Let's see. All right, we get a no. You're not allowed to do this. All right. Any other guesses? You are allowed to do this. The question is why? Because a fighter is a player. A wizard is a player. They're more specialized versions of players, but at their core, they are still a player. Therefore, they are allowed to be passed in as players. They are players, they're just a little bit more. Just as a player is also an object. So if something took in an object as a parameter, a player is an example of a legal object. It's just a little bit more than that. So we actually don't have to change our constructor for an arena. So we're basically saying, look, in our arena, we pit two players against each other. Now we already have created two special types of players, but in video games, a lot of times you might have 5, 6, 7 different types of players or classes of players. So we want to have our arena be written generically, where any two players, regardless of the type of player they are, can be pitted against each other. And then we go ahead and do our fight. Notice that start fight goes back and forth. So if I do nothing else here, if all I did is I create my player, I create my wizard, we'll go ahead and take out the display for those guys. And then we go ahead and we build our ring in terms of a fighter and a wizard rather than a generic player, knowing that a fighter and a wizard have everything that a player has. Therefore, we don't have to worry about our start fight inside of Arena, for instance, when we tell our player to call their display method, players do have display methods. Just like variables, methods resolve to their most local definition. So typically in object-oriented language theory, this is called message passing. We are passing the message called display function to the object called P1. The object called P1 is a player, but we happen to know that we built this guy in terms of a fighter. So yes, we passed in a fighter. So inside here, we can maybe make a little comment. We can say something like, in our example right now, P1 is actually a fighter in this example. I'm going to take this out here in a second because we've written start fight generically. We don't want it to always be a fighter. We want this to be whoever P1 is. And P1 is some type of player. In our case right now, it can be one of three things. It could be a player, it could be a fighter, it can be a wizard. All right. So we don't really need to do anything special here because, for example, when we call the display method for this for P1, which is actually a fighter, if we were to pop the hood on P1, even though externally he's only labeled generically as a player, if we were to pop the hood, we'd find that this guy has rage. We find that, this guy has modified himself from the generic player, but he still has at least everything that player had. We do not have the ability of removing things from our inheriting class. We can modify the things like we've modified strength, we've modified armor class, we've added some things, we've added rage, we added mana, okay, but we were not able to go back and say, I'm going to remove something from my player. Now, we could, for instance, inside fighter, we could have fighter have his own display method that does not leverage the parent's display method. And if we do that, if we write that for fighter, let me just go back here. We'll go ahead and call our display method for fighter and for wizard just to show this real quick. So when a fighter calls their display method, we go into fighter and we see currently fighter's display method right here. All it does is prints out this fighter's rage. We do not leverage our parent's display function to show us the stuff that this fighter also has. So a fighter is only going to show us rage. So not all that helpful of a display function, but just like variables resolve to their most local definition, functions also resolve to their most local definition. So when we say F call your display method, we are passing the message display, call display method to this object, whatever's on the left side of that period. And F is actually an instance of fighter. So we'll start our search inside of here and we will go and see that, oh, I did find a display function. Therefore, we will call this version of display rather than bump up to the next level and go and look in player. So what does fighter's version of displays do? It only prints out the rage. Whereas for wizard, if I go to my second thing here where we create an instance of wizard, I then send the display message to my wizard. So I'm saying, hey, this is a method, call this method. I'm sending the orders to call the method called display to the object that's on the left-hand side of the period, which in this case is W, which is an instance of wizard. I would go into the wizard class. I would look for a display method. I do find one. So there's display. So they resolve to their most local definition. So what does this display method do? Well, the first thing it does is it calls its parents display method because we want to go ahead and get the hit points and the armor class and all that stuff displayed. But then we go ahead and add on to that the mana. So let's go and see the behavior of this. So now we're asking our fighter to display themselves, where we'll only see rage because we did not call the parent's version of display. And then the wizard will show the parent stuff as well as the mana for this wizard. So we'll get that. We'll see the difference there. Okay, so here's our fighter up here. He only has rage because he did not call the player's version of display. He did not ask his parent to call their version of display. We see that our wizard calls the parent's version of display first and then adds the wizard's specialty stuff. Now let me show you a little bit of a twist here. Can I do that? Can I do my own stuff first and then call my parents' stuff? Remember, up here, we mentioned that if you're going to leverage your parents' constructor, if you're going to call your parents' constructor, you have to call it, and it must be the very first thing in the constructor. So when you build wizards in terms of players, the very first thing you have to do is bring the player into existence. Then you can differentiate the wizard from there. The question is, do those same rules apply when calling upon already written abilities of the parent? The answer is it does not. So we can choose to go ahead and have a wizard display their mana first and then do whatever their parent's display method says to do. So the output of this will be very similar to what we have here, except we'll see mana first because that's what we're telling a wizard to do. We're saying show the mana, then do whatever my parent's display method says to do. And my parent's display method, so the display method for player, does all this stuff. So if I run this again, we'll see mana first, followed by the other stuff. So there's my mana first, there's the other stuff. All right. Similarly, I can choose to not have a display function inside of my wizard. So now when we come back out to driver, I create my instance of wizard. I send the message, call your display function. I send that to my instance of wizard. First thing I do is I go into wizard, I look around. Do I see a method in here called display? I do not. So am I out of places to look? Nope. So now I go to player, the next level up. I look through player. Do I have a function in here called display? Yes, I do. So this will call the parent's version of display, even though wizard didn't have a display. Why? Because when wizard extends player, he gets everything that a player already has, including their display method. What did we do with fighter? We wrote our own display method, a more local version of display. We currently chose not to call our parents' version of that as part of this, but we certainly could have. So right now, a fighter only shows their rage, where a wizard just calls the parent's display function because that's their version of display. They don't do anything special. So even though a wizard does keep track internally of their mana, displaying a wizard currently doesn't say anything about mana because players didn't have mana. So if I run this, we'll see that our wizard is still able to display themselves. So there's Chuck, but Chuck displays himself as if he's a normal plain Jane player because wizards don't actually have a display function as we currently have it written. All right, questions about that? All right. So now if you just kind of think through that several times, when you're going back through this and studying this information, whatever, it should make pretty good sense compared to how inheritance works in real life, right? All of us are built in terms of our parent, right? We're built in terms of our parents. So a lot of us have things that we got from our parents. Now, some of those things we have further differentiated from ourselves, especially since we're built in terms of a couple of parents. Um, which actually is not something that exists in more modern object-oriented languages. In early object-oriented languages, we did have something called double inheritance. So we could have a human class that extends mom and dad, for example. We would inherit from two different things. Programmatically, that becomes a problem if you have, let's say, mom has a display method and dad has a display method. Which one does the kid get? Or is it both? So that actually never took off and added more confusion than anything else. So a rule of thumb for modern object-oriented languages is a class can only ever extend one other class. If I really needed to extend a couple of classes, what I would do is I'd create another layer of inheritance. I would say I would create, maybe a class called Dad's Kid, which extends Dad, and then I would have another class that is called Mom's Kid that extends Dad's Kid, or something like that. So I'd have to create the equivalent in layers. Probably not a real common thing. Usually, single layer inheritance is enough. We kind of saw that play out in one of these slides here. Okay, so right now we have player, we have fighter, we have wizard, and the reality is there's actually a level above this called object, and object is built into the language. So player, even though we don't write extends object, it still extends object. And then we have two separate classes, fighter and wizard, that both start off as players and then further differentiate themselves. All right, so the logic of this inheritance is very, very, very similar to how you might imagine it would work if you were just taking guesses about how it works. Okay. Let's see, what do we want to talk about next? Okay. Now, now that we've brought into existence wizards and players, I've already gone ahead and given my wizard back his um, displaying ability. Um, you can decide how you want to call this. What we might do is we might go into player. Maybe we remove this last line just so it doesn't look funny. We go into fighter. We go ahead and tell fighter to call his parents' display method. Then we show the fighter's rage, and then we round that out with that closing ninja move, where so it looks pretty on the screen. Same thing with wizard. We'll end it with this guy. We'll go ahead and put mana after the display. So now the display method for fighter and wizard, what does it do? The first thing it does is it calls its parents' display method, which is this guy, which puts all these asterisks out there, then shows name, hit point, strength, and armor class. And then for a fighter, it then shows rage followed by some more asterisks. For wizard, it shows mana followed by some more asterisks. So it should look, I don't know, potentially more organized or prettier right now, something along those lines. So there is our wizard here, Chuck, with his hit point, strength, AC, as well as mana with that closing asterisk. So this is just us formatting it in a way that seems reasonable. Okay, questions about any of that? Yep, we're going to be getting there, Julian, with how to add spells or special kinds of attacks. It's going to be very similar with kind of what we're doing now. All right, but we got to do one more little step in the middle here. So let me ask this question then. So now we're in this world where we have fighters and wizards. Does it ever actually make sense for us to ever generate a generic player? Because as it stands right now, nothing prevents me from saying player P is equal to a new player, uh, Doug, and then P dot display. I can do that. And now I have my player Doug. So here, meet Doug. And notice that Doug, he has player's version of display, which we took out the closing asterisk on. So he no longer has that last line. So, Doug's a little bit quirky in terms of how he looks here. All right. But it's still allowed right now. So then my question is, remember, we're inventing this video game, so there's really not a right or wrong answer to this. But if we just use our own imagination or our own opinion, we say, look, in our version of this deathmatch thingy, does it ever actually make sense to have a player? Or as of right now, are all fighters or all combatants either fighters or wizards? It's probably more of that, where we have specialized kinds of players. We have fighters and wizards, and everybody who's going to fight each other in our little deathmatch thing will either be a fighter or a wizard. We're never going to have this generic player wander into the room that isn't specialized. All right. But right now, we technically allow it. Right now, we can have a player, named Doug, that can display himself. Now, remember, before I had this arena and I had the start fight thing, I'm going to go ahead and call this because notice we have not made any changes to arena today. All we've done is we just asked the question, well, if arena's constructor expects me to pass it two players, am I allowed to pass it a fighter and a wizard? And we decided the answer is yes. Why? Because fighter is a player. Wizard is a player. So I am, in fact, passing it to players. They're just more specialized versions of players. And then I can go ahead and tell those two, the wizard and the fighter, to fight to the death. Now, right now, wizards and fighters, they know how to fight, just like a player knew how to fight because they got all this extra stuff from player. They got the is dead function from players so they can report information about their hit points. They got take damage. They got get armor class. They got get name. So they got all these things from player, and they only rewrote or overrode one of them, display. And they chose to still use the parents' version of display, but then add a little bit to it. All right. But fighter still has all those functions like is dead and those things because they inherited that from player when they extended player. So what does that mean? Is even though we haven't changed one thing inside of arena, I can still have my death match, have fighters and wizards fight each other. So Chuck, our wizard, won that fight, but Chuck and what's my fighter's name? Bob. Chuck and Bob fight just like players used to fight. Even though they have these different abilities, even though they might be a little stronger or a little bit weaker or have a little bit more armor class or a little bit less armor class, in terms of attacks, they're not taking advantage of any of those things. They all attack the same as a normal player attacked. So arena still works for fighters and wizards, but it isn't utilizing any of the special things of those guys. All right. Similarly, though, I can say I want my fighter to go up against my player. So I'm going to have Bob fight Doug here. All right. Well, as of right now, even though we decided that, you know what, it really doesn't make sense for a generic player to step into the arena. Anybody who's in the arena really should be a fighter or a wizard. But as we have it written right now, not only can we create players, generic players, we can also go ahead and throw them in the ring to fight. No, actually, yeah, Doug won. The generic player beat up our fighter. Okay, right now that's not surprising because he's well, it might even be a little surprising because Doug, he had a pretty good armor class to begin with and decent strength. Let's see, what did Bob have? Oy. Pablo walk. Oh, wait, hold on. That's not his original. Remember, we show their data as we go through. Okay, Bob had 29 hit points. Oh, but he had a very low armor class. This is after Bob's armor class was adjusted. So we added to Bob's armor class, so he must have rolled a very low armor class initially. So that made our fighter weaker than he should have been. And we're not really taking strength into consideration right now. So that's why our fighter was able to beat our generic Doug. But realistically, if we look at this, we don't envision there ever being generic players in the ring. Right now, it's technically allowed. Well, we could just choose not to do this. But if we want Java or other object-oriented languages to police this for us, we have something called abstract classes. I'm going to get to static here in a few minutes. Abstract classes. An abstract class is a class that is designed to be used for inheritance, but never instantiated. So the example here would be player has to exist so that we can build fighters and wizards in terms of player. But we don't actually ever want to allow them to create an instance of player like we've done right here. Technically, we could just choose not to do that, but right now we've chosen to do that and it's allowing it. If we want to disallow that, what we do is we go into player and we list player as an abstract class. And by making it an abstract class, it says that we cannot instantiate it, which means that this line of code right here is illegal now because I'm trying to create an instance of player, and that's not allowed. If I try to run this now, it'll scream at us. Player is abstract. You cannot instantiate it. Okay, so it's not happy with that guy anymore. So now we've disallowed the creation of generic players. And since P no longer exists, we have to put our wizard back into the ring. All right, so now we still built players to create the generic version, the core of all of our combatants. Okay, but we never actually we create player because we want the core of all of our combatants, but we never actually intend to create generic players. We want to use that player for inheritance only to create fighters and wizards. And by making player abstract, we've now accomplished that. All right. So that's what an abstract class is. And the only thing you need to do to make that happen is just put the word abstract in front of it. This one word right here just says you can't create instances of this. You can create instances of things that are based on this, that is a fighter and a wizard. And this can happen at additional levels. So I can have an abstract class called player. I could also then make my fighter abstract. You can say abstract public class, or you can say public abstract class. It doesn't matter the order these come in. These are just kind of, we're delineating various rules that this class plays by. So now I could say that a fighter is also abstract, maybe with the idea that, okay, well, fighters are going to come in some different flavors. Maybe I'm going to have a a berserker and I'm gonna have a, I don't know, a paladin or something like that, which is like a half magic, half warrior type dude. So, I can say, hey, a fighter is more of this melee type guy. He's going to use, swords and stuff. But even then, fighters are not going to exist by themselves. We're going to further specialize fighters into berserkers, for example. Um, so that would be one example where you can have multiple abstract classes. So nothing keeps us from having a abstract class inherit from another abstract class. But now, because fighter is abstract, this line is now illegal because I can no longer create instances of fighters. So fighter is abstract, so it cannot be instantiated. Now, that's not what we're doing currently, but just understand that that abstract keyword is built for supporting inheritance because there is one of the goals of inheritance. Let me go and add this somewhere in here. Goals of inheritance minimize duplication of code. And what do I mean by that? If I go back out here and I look at my player, inside of player, I have, all my stuff about getting the hit points and the strength and the armor class. I have these abilities, is dead, take damage, get AC, get name, display. So I have all these things that players have. Well, if I don't have the player class and I just write wizard and fighter by themselves, I would have to duplicate all this extra stuff. I'd have all the stuff I have highlighted right now. I'd have to have that exist inside of fighter, and I'd have to have it exist a second time inside of wizard. So I'm duplicating a lot of code. Where with inheritance, I can say, well, I'm going to stuff all the things common to both fighters and wizards into player. And then I'll define fighters and wizards in terms of players and then further differentiate themselves in whatever way I want. And that's the concept of inheritance. All right. So inheritance is not necessarily better than not using inheritance. You always want to use the right tool for the job. So when something can be defined in terms of something else, and you're going to have multiple things that are defined in terms of other things, then you would create a class that you're going to use as your base. Similarly, if you never intend on creating instances of your base, that base only exists to support the inheritance model, then you would make that class abstract so it self-polices. It won't let you accidentally make a instance of it. Now, an important distinction here, though, is, and this is kind of a sticking point for a lot of beginning programmers where it gets confusing. We've made player abstract. What does it mean for it to be abstract? It means that it cannot be instantiated. That's what abstract means. You can't create an instance of this guy. Sorry. So what is an instance? Well, we saw that we could not do this. We cannot create our instance of player here. I still left fighter as abstract. Let me get rid of this guy for right now. So we see that player, because it was abstract, cannot be instantiated. So on line 20 here, my question is what's the instance of player? Understanding this will make the other parts make sense because right now, for many of you, it's we've said player is abstract, so you can't create instances of it, yet it might be confusing why I can build arena in terms of two players if I can never create instances of players. So that gets back to our question of on line 20 here, what is the actual instance of player? What is this variable P? What is P? P is a variable. What do variables hold? They hold values. On line 20, the value that P holds is the instance of player. So what does that mean? When I have player be abstract, what I'm really saying is you cannot call the abstract player's constructor directly. I can indirectly call it. We've seen ourselves indirectly call it. Inside a fighter, we indirectly called player's constructor using the super keyword. In wizard, we indirectly call player's constructor using the super keyword. But I never called player's constructor directly anywhere in my program. Inside of Arena, yes, arenas are built in terms of two players. But in this case, P1 is a variable. P2 is a variable. I am not calling player's constructor here. In fact, what I'm actually passing in to our arena right now is not a player. Well, it's not a normal plain Jane player. It's a fighter, which is a player, and a wizard, which is a player. All right. So to be most precise, just so we can read the code right, when we say a class is abstract, we're saying we cannot call an abstract class's constructor directly. And what's important about that is us understanding the difference between a variable and the actual instance of a player. What I have highlighted there is our actual instance of player, the thing that ultimately will get stored inside of this variable. So P holds an instance of player, which was built using our player's constructor directly. Whereas W here holds an instance of player that was indirectly built in terms of a wizard or through the wizard constructor. And wizard is not abstract. F is a variable that is holding an instance of player that was indirectly built through our fighter's constructor. All right, from an object-oriented programming perspective, the last 5 minutes as we've been talking, super important. If you could wrap your mind around all that, you've unlocked all of object-oriented programming to yourself, or at least the class hierarchy side of things. We haven't talked about interfaces or some other stuff, but class hierarchy stuff should make sense. All right, any questions about that? Let's see, we got some chats going. Dun, dun, dun. R.I.P. Bob. Okay, yep. So it doesn't look like there's any specific questions about that. All right, so as it's yelling at us here, we cannot create our instance of player, regardless of where we're going to store it. In this case, I'm taking that instance, I'm storing it inside here, but I also can't, I could never call this constructor directly since player is abstract. So that is disallowed. Okay, so this thing should be running again now, where we have our fighter and our wizard going against each other. Okay, So now the question was asked, well, how do we have, for instance, wizards cast spells and fighters, um, you know, just take a swing with a sword or something like that? Well, let's look at it. Let's just get wizards casting spells first. All right. Well, right now, how does a attack happen? If we go to arena and we start a fight, we decide we roll this d20 for an attack roll. When our current attacker is trying to hit our current defender, whoever those are players of some type. Current attacker is some kind of player, current defender is some kind of player. We roll a d20 to get our attack roll. We then compare that against whoever's defending's armor class. Now, we're going to keep this generic and saying trying to attack someone means the same thing, regardless of whether you're trying to use magic or whether you're trying to use fists. You get more complicated with your game. You might say, well, you might have certain players that are, have a lot of armor, so they're hard to physically hit, but maybe they have low magic resistance. So you can actually cast spells on them more easily than you can hit them with a punch or a sword or something. But for right now, we're just going to say the idea of successfully hurting the defender means you just have to clear their armor class with an attack roll. Okay, but now we get into where does the damage come from? All right, so right now, whenever somebody hits the opponent, we're saying their damage is always a d4, some number between 1 and 4. We don't take into consideration strength. We don't take into consideration anything else. All right. So what we might want to do is we might want to, instead of just rolling a d4 for damage here, we might want to ask the current attacker to give us some damage. So what we might say is let's go ahead and let's say we're going to move d4. I already put, I put here inside of start fight. I'm going to go ahead and just move that d4 up here. We'll give it its value inside here, this dot d4. And I could have left it where I had it. It wasn't hurting anything. If I could define it up here if I wanted. Just good programming practice is typically to have your list of fields here and give them values inside the constructor when you're initializing it. But nothing actually prevents me from doing that. All right. So now what I'm going to do is I'm going to teach a generic player. Actually, we didn't even need to move the D4 there. Am I using the D4 anywhere else in here? I use it right there. Yeah, I'm not actually using anywhere else. So I'm actually going to just get rid of this D4 from here. I'm going to put it back in a different place. So now what I'm going to do is I'm going to go back to player. And at the top here, actually, we don't even need to do it at the top. We're going to teach players public int get damage. And this is for a generic player. So I'm going to go ahead and say dice d4 is equal to a new dice with 4 sides. And then I'll return d4 dot roll. All right, so now all players know how to get damage. We don't have to know how they're getting their damage. Internally, the logic says they're just rolling a d4, which is the same thing we were doing before. But now inside of Arena, rather than getting our damage by just rolling a d4 here, instead, we're going to ask our current attacker to get damage. Who's our current attacker? Our current attacker is some kind of player. And players now have the ability to give us some amount of damage, however they figure that out. Okay. So what we can say here is with Arena, without changing anything else, let me go ahead and get that. I took the D4 out there. I didn't see any other occurrences of D4. So if I run this right now, I should actually have the identical logic that I had before when they fight each other. I'm still just rolling a D4 for damage, but now I've taught players how to generically generate their damage rather than hard coding it inside of the fight. So we'll go ahead and do that. Oh, I did have another D4 in there. Oh, actually, just misspelled return. All right, so here's our fight. Nothing's actually changed here logically. All I've done is I've moved the ability of getting damage into player so that in the fight, whenever we need to get damage from our attacker, we just ask our attacker to give us some damage. All right, so nothing's changed yet. But now what I can do is let's go ahead and teach wizards how to cast spells. All right. Now, one thing we can do here, let's enhance damage a little bit or get damage, is inside of player, besides just returning the value, we can go ahead and do like a system.out.println. Say something like this dot name swings and hits for, go ahead and say int damage is equal to d4 dot roll. So he swings and hits for that amount of damage. And then we'll return the damage we generated. So I'll roll my d4 right here. We'll store the result. We'll remember the result of that roll inside of damage. Remember, all programs are made up of memory, asking questions, repetition. So we're going to remember our d4 roll because we're going to use it again later. I'm going to go ahead and display to the screen that whatever the name of this player is, he swings and hits for some amount of damage. And then we'll go ahead and return that damage. So if we change nothing else and we go ahead and just run our program here, we'll now see Bob swings and hits for 3, Chuck swings and hits for 1, so on and so forth. Since now we're generating damage from our player, we just went ahead and encapsulated the logic for generating damage along with any verbiage we want to have into this get damage so that whenever we're inside of Arena and we ask for getting damage, it does it for us. Okay? For wizards, because a wizard is a player. So as it's running right now, since my entire fight is built up of fighters and wizards, we're never actually calling generic players. The only reason we're getting to the get damage from generic player is because fighter and wizard have not written their own more local version of that. All right. So what I'm going to do is I'm going to write a more local version of this inside of wizard. So wizards are going to know how to deal damage themselves. And they can only deal damage if they have available mana. All right. So let's just assume that right now wizards only have a single attack spell. All right. So assume a wizard has a single attack spell that costs 10 mana. Okay. if they have at least 10 mana, they can cast the spell. Otherwise, they just do a normal hit with fists or something like that. All right. So now we get to ask the question. If this dot mana, I'm currently inside a wizard, so this dot mana, which is a wizard's extra resource that has some value between between 1 and 100, if that value is at least 10, we have enough mana to cast the spell. So we'll go ahead and say this dot mana is equal to this dot mana minus 10, the cost of casting that spell. So we're reducing our currency. Then let's go ahead and generate our damage. And let's say that our spell does a D10 worth of damage instead of a D4. All right. So we're going to go ahead and say dice D10 is equal to a new dice with 10 sides. And we'll go ahead and return. Well, actually, we're going to do a little system.out.println. This dot name casts a powerful, what do we call this? Death bolt. So let's just call it that. Or we're going to go ahead and get our damage. So int damage is equal to d10 dot roll. And we'll put damage there for that. And if we want to highlight our magic damage a little bit, we could do something like that. Just put some asterisks around it. Or whatever you want to put there. Okay. But this is only if they had enough mana to cast the spell. If they had enough mana to cast the spell, then they charge themselves that mana, so their pool of mana is now less. They then roll a d10 in this case because we'll just say magic hits harder. So it's a d10 instead of a d4. In this case, you can tweak your game however you want. So then we'll roll our damage and then we'll output stuff. Otherwise, if we didn't have enough mana to cast our spell, then what are we going to do? We want to go ahead and take a normal swing like a player would take a swing. That is our parents' get damage function, which returns a value, so we'll return that amount of damage. We need to remember to do that up here as well. So we'll return the damage that we rolled. So if we're using mana, we're going to cast a spell, we generate our damage, we put a little word salad out there, and then we return the amount of damage we did. Otherwise, we just return our parents' get damage. Okay. So now wizards have a specialized attack. When we ask a wizard to get damage, now keep in mind, inside of Arena, even though current attacker and current defender are advertised as plain Jane players, what's actually stored inside of them will either be a wizard or a fighter. So that means if the current attacker, this guy, happens to be a wizard, when we call get damage, it will call the wizard's get damage function, which checks to see if he has enough mana to cast the death bolt. If he does, he does it. Otherwise, he just defaults to his normal playerness get damage. Whereas a fighter does not have a more specialized version of get damage. So he'll default to a player's version of get damage every time. So out here, we're going to still have our fighter, still have our wizard, still have our arena. All we've done is made our wizard able to cast damage a little bit differently. Go ahead and run this. Oh, this dot name, we need a concatenation there. All right, so let's see if our wizard can land some, here, what do we got? Bob swings. Well, let's just get to the, man, that fight lasted forever. Jeez. Swings and misses, swings and hits. And he got no death bolts off yet. He must have gotten one death bolt off at some point. Or I wonder, did he never have enough mana? Oh no, he has plenty of mana. He's just, does Bob have a super high armor class? Oh, yeah. Bob has an armor class of 21, and we're only rolling D20s to clear it. All right, so our wizard here is in trouble. Is in trouble. He's never going to get a spell off because Bob's too tough for him. So let's run this again. Maybe get him a little bit lower armor class. All right, so now, oh, that's Chuck with armor class 6. Okay, Bob can be hit now. All right, so let's. Ah, here, Chuck casts a power death bolt for 5. All right. And then what you could do is you could even further, you know, say something like, you can ask a question in your wizard, if damage is greater than 8 or something like that, then you might just add a little bit more, commentary. Um, uh, Something like, I don't know how gory you want to get with this thing. Like blood explodes or something like that. Yeah, let's go with something like lightning. Um, Electricity sizzles um, in the air or something like that, only if it's extra powerful or something like that. So if he rolled at least an 8 on his D10 roll, that means that that death bolt was kind of an extra powerful death bolt, and the electricity is sizzling in the air. So we'll only say that sometimes. Here, let's mark this off some. So that's what an electrical bolt looks like, let's say. So when he hits extra hard, we get that electricity sizzles in the air type thing. Oh, look at this. Chuck finishes him off. Hits him for 10. Oh my gosh, Bob probably just exploded. All right, so there you go. That should answer your well, start with answering the question of how can you make wizards do something special. So in our last minute here, are there any questions about any of that stuff? If I were giving you homework, so if you wanted to mess with this over break, I would be giving you the assignment to effectively add a get damage to fighter that does something similar to what we did with our wizard. All right. So that's where we would probably start next time. So if you wanted to go and do that, you can just do it something like we've done with get damage here. All right, let me put this up on Slack and then I'll check to see if there was a question. Oh, what about criticals? Okay, does that cover your critical, Julian? I suppose we could do that if he rolled a d20, so if he maxed his attack roll and he maxed his death bolt, we could say that's like an instant kill regardless of hit points or something like that. That could um for AC not lower than 10, that would just be changing our random number. Right now, our armor class, our base armor class is done here in the constructor for player, right here, where we roll a dice 1 through 13 and we add 4 to it. So right now, the lowest armor class could be 5. We could adjust this to add more to it, or we could just randomly adjust it that if it's less than 10, set it to 10, something like that. Similarly, we could also say if it's over 20, set it to 20. Um, that would only happen inside of fighter where we make this guy too strong. That's what happened here where the guy had an armor class of 21. So you can go and tweak some of those things to make it um, work out. Wire system and string both red. It's got to be just color coding from this guy. We just put it in wizard. Yeah, this is the name of a class. We're in their Java mode, so they must color code the built-in classes. System.out.println, and the name of the class here is system. Let's see, they do it for other classes in driver. No, only built-in classes, it looks like. So string is a built-in class in Java, so they have that highlighted. Probably random then should be if we go to our dice class. No, no, random's not either. So only things built into java.lang, I guess, are red. But that has nothing to do with Java. That's just online GDBs, color coding, whatever. All right. I think that covers all of the crispy. uh, Chromatic orb should have been the name of our attack. We'll have to make that another attack that costs more mana. Okay, so we'll leave it at that. I put the link to the code up. Everybody, if you're traveling for Thanksgiving, have a safe trip, spend some time with family, whatever. I told you what the assignment would have been if you want to mess with it. Otherwise, I'm not giving you any official homework over break. So take a break, and I'll see everybody next week. Questions? Okay. Nope.